types of different ways we can able to configure the Hadoop, and what are the Hadoop installation types, and how we access the files in each installation type. So that's we are going to discuss in today's session, and how you are going to, when you are going to write the data, how the data is written to the data nodes. We'll see these things in today's session. Okay, so okay, so we can able to configure the Hadoop using three ways. One is a standalone installation, and other one is pseudo distributed installation, and the third one is fully distributed mode installation. So when we are going to configure a Hadoop cluster, so now you have to configure Hadoop. So you have the three different ways you can able to configure the Hadoop. One is we configure Hadoop as a standalone mode, that we call it as a local mode installation, and the second one is pseudo distributed mode installation, and the third one is fully distributed mode installation. Right. So what is a standalone mode installation? Suppose I want to configure some Hadoop cluster, right? So where I want to test, where I want to debug the MapReduce jobs. So for that, we configure Hadoop as a standalone mode. So in this one, so what we'll do now, we are going to write the different programs, or we are going to write the different jobs. Now you want to test how this job is going to run on the cluster. So what will be the performance issues, whether we are going to get the data or the output which we are expected, and what about the different kinds of debugging issues. So to identify that, we take a standalone mode Hadoop installation. So we use this standalone mode to test and debug the MapReduce jobs. Right, so you can write a Hive program, or you can write a Java, or you can write a MapReduce program. So we have local file system representation is there, where we are going to access the files with file colon triple slash. So you take a file, just copy it into the local file system, and we will access that file with file colon triple slash, and we specify the path of the file into Hive program, or it can be a MapReduce job, and then we can see the how the job is going to be performed. Just we use this kind of installation to test and the debug the MapReduce jobs. So in the standalone mode installation, so it's not mandated that we should have SDFS. So there is no SDFS required, because and we use, instead of SDFS, we use a local file system to store the input data, and we are going to process the data from the local file system. So here we won't use the replication, so there is no replication, right? So just we see how the job or the program written by you is how it is going to be executed. And the second one is pseudo distributed mode installation. Okay, so in the pseudo distributed mode, we are going to configure all the Hadoop daemons into a single machine. So it can be something like called one node cluster. Suppose if you take a fully distributed mode, we call it as a multi-node cluster. So multi-node cluster in the sense all the Hadoop daemons. So name node is configured into one individual machine. data node is configured in one machines, some machines, and a dedicated machine for dedicated node is given for the secondary name node, and some dedicated machines for the data nodes. So suppose if a Hadoop cluster is running with 100 nodes, means there is a one name node and one machine is a secondary name node. In one machine we are running the job tracker, and all the remaining machines we can consider as a data nodes. That means in a multi-node cluster, all the Hadoop daemons, or you can say Hadoop processes, are going to be distributed to individual nodes. That means one node is for the name node, one node for the secondary name node, one node for the job tracker, and some set of nodes for the data nodes. So each node have its own individual Hadoop daemons. So that kind of Hadoop installation is known as a fully distributed mode. And so the cluster, we call it as a multi-node cluster. So then what is a pseudo distributed mode? Now all the Hadoop daemons, like so whatever the SDFS daemons we are having and the MapReduce daemons we are having, all these Hadoop daemons are configured in one machine. Okay, in a single machine we configure the name node, we configure the data nodes, we are going to configure the job tracker, we are going to configure the task tracker. So all the Hadoop daemons are available in one machine. So that kind of installation is known as a pseudo distributed mode installation. So now what we use now, so the environment which we are working is a, it's a pseudo distributed mode installation. So I'm having one data node in this machine, I've configured one name node in the machine, and I have a job tracker and the task tracker, resource manager, node manager, that's a yarn. So all the Hadoop daemons are running in one machine, right? So this kind of Hadoop installation is known as a pseudo distributed mode installation, right? So we call it as a pseudo distributed mode. Now in the pseudo distributed mode, we are going to configure it as a local host. So now all the Hadoop daemons are, each daemon are individually available into its individual port number, one port. So one dedicated port for the name node we have given, and one dedicated port for the secondary name node is available, and we are trying to connect to the name node through the data node, and the files which we are going to write into the SDFS, and that can be stored into the same node as a local file system. That is, suppose in the system it takes some location in root level somewhere, a directory is going to be created. In the directory, all the files related to the name node or the name node metadata is written into one file, and the data which you are going to write into the data nodes internally written as a black pool file into the one location. Now it's a one machine, it is a single machine, but all Hadoop daemons are running in this machine, right? So that kind of installation we call it as a pseudo distributed mode installation, or it can be a one node cluster. It can be known as a one node cluster. So now in this one we have SDFS is available. So in the same disk, the data nodes, we are using SDFS, and we are going to store the data in SDFS, and also we have local file system to access the files, and we can able to copy a file from the local file system to SDFS file system, and SDFS file system to local file system. And the data are the blocks, are the file blocks, are the input data which is going to be split as the blocks are written into this SDFS are replicated once. So here the replication factor means every block which you are going to write into this one node cluster, or every block which it's going to write into the pseudo distributed mode and installation can be replicated once. That is, we call it as a replication factor. So by default every block is replicated only once, and we have the job tracker is available, as well as the task tracker is available. And suppose if you want to run a job on yarn, we can able to run the job on yarn. So if you're able to configure the Hadoop in a pseudo distributed mode installation, the same thing now. So if it is a fully distributed mode, now so all the Hadoop dimensions are going to be distributed individual nodes. So one node for the name node, one node for the data nodes. So each node is having its own IP address. So here how we are going to connect access this cluster. So generally we use localhost, right? So now suppose if you want to access something, so we are going to write like sdfs colon slash slash. So I'm writing here localhost and the port number for the name node 8020 and the directory which is in where we are going to store the data, right? Like this we are accessing. So now what we wrote here, the host name is a localhost because I have configured Hadoop in a one node cluster, which I am using it as a pure distributed mode installation, right? So everything is available in one machine, so we can access it through localhost. But if it is a fully distributed mode, now each machine is having its own host name. So if you want to trying to connect to this fully distributed mode cluster, so we connect like this sdfs colon slash slash. Now do we have the local host here? No, we don't use localhost because there is a separate host name is available for the name node, and there is each node is having its own IP address and its own host name. So now we'll write the host name of the name node, the machine or the node which you configured as a name node. So we'll have some host name. So you have to write the host name of the name node colon the name node port 8020, then slash, then write user, then Cloudera to access the files. So this is how we write in a fully distributed mode installation, right? So in a pseudo distributed mode, we wrote localhost. Here instead of the localhost, so we have to write the host name of the machine which you configured as a name node. So in a multi-node cluster, right? So we can perfectly run a MapReduce job. That means both the job tracker as well as task tracker is available, and so we have yarn is available. And you want to run a job on the MapReduce, yes, you can able to run a job on the MapReduce. Or if you want to run specific jobs on yarn, right, we can able to run some jobs on yarn, we can able to run some jobs on MapReduce. And every block means every input data which we are going to write into this cluster, which is a multi-node cluster, each block is replicated 3 times. So the replication factor is 3. Okay, so what is the replication factor? Means so you're going to write some data, the input data, right? So the file is going to be distributed into small size of chunks. We call the chunks as a blocks. Each block is going to distribute it into the data nodes. So now in a fully distributed mode installation, every block or the data chunks are going to be replicated 3 times. So if one data node contains the same block and another data node also contains the same block, because we have the replications are available. So when the replications are available, if one data node goes down, it doesn't make any issue in your job processing because we have same blocks are available in another data node. So in that's a we use in a fully distributed mode installation, right? So now if you see here, now the one which I'm using the CDH4, so this is configured as a pseudo distributed mode installation. So now in this machine, all the Hadoop daemons, so you take SDFS daemons as well as you take MapReduce daemons, everything is available in uh, in this only one particular machine, right? So this is a pseudo distributed mode installation. Okay, see, okay, so now whenever we are going to configure the Hadoop, right? So we use something like this. So we have multiple racks are available. So this is some rack 1 and some rack 2 rack 3, where it is. Okay, so rack 1, rack 2, rack 3, right? So these racks are connected together as a cluster. So where here the cluster is a logical thing. Okay, so now, so some set of nodes are configured in one rack and some nodes are configured in another rack. So now in this clustered, right, so we have some racks are available, so rack 1, rack 2, up to rack n. So each rack is having some set of nodes. So in this rack 1, now I am having the 3 data nodes and 1 name node, and in the rack 2 we are having the 3 data nodes and 1 job tracker. So in this rack, all the nodes are the data nodes. So this is a Hadoop cluster. So where some set of racks are connected logically as a Hadoop cluster. So this kind of Hadoop installation can be known as a multi-node cluster, or you can say it as a fully distributed mode Hadoop installation. So in the sense, now see here, so this particular rack 1, so what are the Hadoop dimensions are available? See, name node and data nodes are available, right? So in this rack 2, one job tracker is available as a master and remaining 3 data nodes are the slaves. Okay, so now, so this is the third rack, and we have 4 data nodes are there, so there is no master. So now, so this is a cluster of 3 6 and 10 data nodes with a one name node, one job tracker, right? So now this we call it as a pseudo distributed mode installation. Okay, so now whenever the user is going to write the data into the Hadoop cluster, either it can be a one node cluster or it can be a multi-node cluster. Now, see, I'm going to write a file with the name some prod info.txt. So it can be, okay, so I'm taking 4 data nodes, and so we are having a one master node. So now I'm going to write a file. So the file name is prod underscore info, and the size of the file is 1000 MB. Okay, now what I want to do is I want to copy this file prod underscore info to the Hadoop cluster where I am having 4 data nodes and one data node, right? So what we know that when we are going to write the data into the Hadoop, so Hadoop is a distributed data processing, that is the input data which we are going to write is distributed or divided as a small size of chunks, right, as a small size of chunks. So we call this small size of chunks as blocks. Okay, so we call these chunks as a blocks. So in a SDFS, every block, the default block size is 64 MB. The default block size is 64 MB, and we can change up to 128 MB or 256 MB or 512 MB, means one individual block size which we are going to write into the data nodes contains either it can be a 64 MB or 128 MB or 256 MB or 512 MB. So whenever you configure the Hadoop, so we have a Hadoop configuration file with the name sdfs site.xml. So in this configuration file, so we have a property that is dfs.block, right? So we have a property dfs.block size. Suppose if it is written as a 64 MB, means every block which is going to write into the cluster is divided into small size of chunks, and each block or each chunk contains size up to 64 MB. So that property is defined in SDF7 site.xml is a configuration file, and the property name is dfs.block size. That is, suppose if it is 128 MB, means every block which you are going to write, right, will hold the size up to 128 MB. Right, suppose if we take 64 MB now, so I'm going to write a file of 1000 MB. So what is the block size? 64 MB. So if you divide 1000 divided by 64, so how many blocks are going to be created? So there is 15.6, means 16 blocks are going to be created. Total it will create the 16 blocks. That is, we'll get the blocks something block 1 and block 2 up to 16 blocks are going to be created. And whenever a block is going to return into the cluster, each block is going to be replicated. Replicated means, so we are making the block as a multiple copies. So if it is a fully distributed mode installation, this block 1 is replicated 3 times. That is, we have the block 1 available 3 times. The same thing, the block 2 is available 3 times. So block 16 is available 3 times, right? Every block is going to be replicated 3 times. So total how many blocks are created now? 48 blocks are created. So now these 48 blocks, that is block 1 to block 16, total 16 blocks including the replication 48 blocks. These 48 blocks are equally replicated to the Hadoop data nodes. So something now, so this data node will contain the blocks, block 1, suppose some blocks 4 and some blocks 15, right? Same thing, this data node contains some blocks, something like block 14 and block 2, right, block 15, like this the blocks are going to be distributed. Now suppose if you are working with this data node and you are working with this block 14, right, so if this data node goes down, so we can find the same block 1 is available in some another data node. So now we can able to retrieve this particular block which is available in a different data node, and we are going to access that block. So this is, so if you configure Hadoop as a multi-node cluster, so the advantage is what? High availability. We make the multiple copies of the blocks, so it's up to you, right? So by default, so we have a property in a configuration file. So what is the configuration file? It's a sdfs site.xml, right? In this one, so we have a property. The property is dfs.replication. If we specify 3, every block which is going to write into the SDFS is replicated 3 times. So that is DFS dot replication. So as you specify the replication is 3, so the each block is replicated 3 times, and these replicated blocks are equally distributed to the data nodes. So that, so some block 1 is available in data node 1, the same block 1 is available in data node 2, and the block 1 is available in data node 4. So if the data node 1 goes down, if the data node 1 is failure, but we have the replica of block 1 is available in another data node, correct? So that now we can able to retrieve the block 1 and we can able to continue our job. In this way, we are going to give the high availability of the cluster, high availability of the data. Even though if your data node goes down because of the having the replications, we can uh, connect to another data node where the same blocks are available, and we assign the job to the task tracker which is available on that particular data node to assign the job on that particular data or on that particular block. Right, so this is how the data is written into a fully distributed mode Hadoop cluster.